Okay, we have learned about Venn diagrams, and then yesterday we learned about expected value. So now we're going to kind of make sure that you get how to do the harder expected value problems, and then the plan basically is that tomorrow a lot of the kids on Wednesday are going to be watching this video again because they're not here right now. I'm looking at a fairly small class because a bunch of people are at the plan test. So anyway, here is today's expected value kind of part 2 or B. Here is a problem. A sweepstakes, a national sweepstakes, awards one prize of $1 million, 10 prizes of $100,000, and 1,000 prizes of $1,000. If 10 million people enter the sweepstakes, what's a fair amount to pay for a ticket? All right, well, I'm going to just do the setup on this one because I did it last hour and it is so, like the numbers are so weird. Like 1 in 10 million is such a small number that it basically rounds to 100%. So like, it's like when you round it, there's a 100% chance you're going to lose, which is, you know, okay. If you round it, I'm sure that's true, but the numbers get kind of weird because they're so small. But basically, what can happen? You can have several things happen. You either win the million, you win the 100,000, you win the 1,000, or you win nothing. Do you get that those are the amounts? And expected value, isn't it P times A, probability times the amount, and then you add them all up, right? So what's the probability of each of these things? Well, the probability here is 1 in 10 million. Don't write it. It's just a pain in the butt. It's just so many zeros. And when you actually make a decimal for it, it's 0.000000. I think it's like 8 zeros. So anyway, the point is it's a dinky number. I'll tell you what comes out when you multiply them, though. What comes out is 0.10, as in 10 cents is what that part's worth. This next one, there are how many tickets that win out of 10 million? There's 1,000. So this one's a little bit bigger number, but when you multiply this times a little bit smaller prize, you still get exactly 10 cents. And then the last one is a bunch of people win this. Wait a minute, this was 100 people win this, sorry. This is 1,000 people win this out of 10 million. And they get a value when you multiply by 1,000 of 10 cents. So this one, even if the number is hard to calculate, it doesn't matter. You're going to times it by 0 anyway. It's worth 0. What do I do after P times A? Add them all up. Add them all up. The sweepstakes ticket is worth 30 cents. So if they charge $1 for it, well, then you'd be losing money. But the reality is in a sweepstakes, they usually don't charge you anything. You just have to fill out some forms and you get entered in the sweepstakes. So why would a company give away like $2 million? Because basically they get tons of advertising out of that. They get a lot of people that are excited about having a chance to win the sweepstakes, and so they send these things out for free. But it really only costs them 30 cents for each person they put in the sweepstakes. If you think about it, you send out a stamp nowadays, you mail out a stamp, they're actually paying more for the stamps than they are for the value of the sweepstakes. Yes?
I used to sign up for the publisher's clearing.
Yeah. Are you old enough?
You can be a teenager.
You can? Okay. Did they send you stuff? This is a kid in class talking about how he entered the Publishers Clearinghouse one. Did they send you like things saying you might have won? They usually send you like, you know, you might have won, and then you're like, what does that mean? Does that mean I've like got through the first drawing and I might have won? But all it means is if you entered, you might have won. But old people get sucked in on this stuff all the time. My grandpa was kind of like into sweepstakes, and they would offer things like you might have won. And if you'd like to buy this thing right now for like, you know, $10, we'll put your name into the sweepstakes again. And you might have won already. Anyway, so he would buy all this stuff from the sweepstakes companies. Yes?
For the $100,000 one, scissors with a check price.
All right, so I did, this one should be 10. Is that what you're saying? Okay. And then I think this one was right of 1,000. So I was trying to make the point that these are such a pain in the neck to actually do in your calculator. I was saving you the time. But you can trust that this one comes out right. I can even show you the answer that was pre-done there, 30 cents. 10 cents for each, except for the one that's 0. All right. Yes, sir. Grandpa never won the sweepstakes. Nope. But you know what? He had a lot of fun playing, and it really wasn't that expensive, because the stuff he bought from them was usually pretty cheap stuff, like 10, 15 bucks. So where it's really awful is when people take advantage of old people for like thousands and hundreds of thousands of dollars, because sometimes they really think they're going to win a prize, and like the person will say, well, you've got to pay shipping on this really expensive prize, and it's totally a scam. And the old person says, okay, well, as long as I'm going to get my $1 million, I'll pay the $1,000 worth of entry fees and blah, blah, blah. And pretty soon they just got completely scammed. All right, moving on to a 2-player game is set up with the following rules. This one's kind of a pain in the neck, but I want to just generally talk about it. If you rolled 2 dice, do you get that your probability of getting a 6 and a 6 is a 1 in 36 chance? And I know some of you are going to say 7 comes up the most, and you're right, 7 does come up the most, but that little combo right there of a 2 and a 5, there's only one way to get that exact combo of a 2 and a 5, right? Not a 5 and a 2, a 2 and then a 5. So there's only a 1 in 36 chance of this also. Is there a lot of 7s on the board here? Yeah, there are. There's only 1 12 on the board. There's a lot of 7s on the board. So, but this exact roll, there's still only 1 in 36 chance. All right, so here's the game. 2-player game set up with the following rules. Player A is odds, and B is evens. And they each have a penny out. And if it comes up when you roll a dice, if it comes up odd, the odd person gets both pennies. The one that they had in the first place plus the other guy's penny. If it comes up even, the other person, the evens person, the player B, wins. And then here's the kicker. If the doubles are rolled, the dice are re-rolled, as in nobody wins if doubles are rolled. Is this fair? Let's just think through it quick. Okay, if doubles are rolled, I'm going to just throw out all the doubles. Do you get that nobody wins if we get this, or this, or this, or this, or this, or this? And here's the key to the whole thing. When doubles are rolled, what's the total? It's always an even. See how even guys getting a bad deal here? Because there would be an equal number of evens and odds, except that we just threw out a whole bunch of evens. So now if you want to play this game, which do you want to be? You want to be the odds person. And you could definitely bamboozle somebody with that. All right. And what's the expected? Is it fair? The game is fair if the expected value is the same for both players. All right. Next one. Player 3 enters the game with his wager of 1 penny and declares a new rule. If doubles come up, player 3 wins the pennies from the other 2. Now, is it fair? Okay, well, let's go back to this thing and see if evens, anytime evens comes up, let me get rid of some of these things here so we can make, the ones that are scribbled out here, circled that thing so many times. There we go. The ones that are scribbled out, those are going to be 2 cents win for that guy, the doubles guy that comes into the game. He gets 2 cents winnings. No, because one of the pennies was his, and then the other 2 guys have to give him theirs. So he gets 2 cents each time. 2 cents, 2, 2, 2, 2, 2. Okay. Then I'm going to use a different color. I'm going to use black for the evens guy. Or, no, wait. I guess they did it in blue, so I'll use blue. I just did that for the other person, but that's all right. Player A is odds. So here's the odd ones. Odd, 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 odd. 5 and 6 makes 11, for example. Odd, 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 odd. Odd, 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 odd. And odd, 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 and odd. Okay, so the odd person, how much do they win when they win? They win 1 cent each. I'm not going to write a 1 above every one of those, but we'll have to just know that. And the last one is evens guy. Even, 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 even. These are all 1 cent wins. Even, 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 even. Even, even. Okay. The probability of each of these spots is equal. They're all a 1 in 36 chance of happening. So, probability times the amount. If the amount is 1 cent each, this person's going to win 1, 2, 3 cents, 4, 5, 6 cents, 7, 8, 9, 10, 11, 12 cents. 12 cents for even guy. 12 cents total. I just did the probability times the amount and stripped off the probability because the probabilities were all the same. Then odd guy, actually I should do that in blue. Odd guy is gonna, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all odds. 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 cents for odds guy. So is it fair? For sure, it's not fair already. But let's just look at this last one and see if the new guy with his new rule it comes up a winner. 2 cents for each of these. So 2 cents, 4, 6, 8, 10, 12 cents for doubles. He gets 12 cents. So odds still got too good of a deal. Does that make sense? All right. So when trying to figure out fair, is the game fair? You're trying to get the expected value for the one and the expected value for the other, and you see what if their expected values are exactly the same. All right. And we already talked about that. And now this kind, man, this comes up a lot. These warranty questions. I want you to do one with me right now. So everybody, on your iPad or your paper, whichever you have out right now, I'd like you to try to draw me the tree, and I want you to start with works on top, just so their answers will look the same when they're done, and breaks. Put the probabilities here, the amounts you get here, and then when you multiply them, you add them all up at the end, and you see what the warranty's worth. Don't be surprised, the warranty on this one is worth a very small amount of money. But you have to pay $75 for it. That'll tell you what after it's all done, you'll know what it was worth. Then you'll realize, crap, I had to pay 75 bucks for that. And then you'll see your negative amount is how much your expected value is. You're going to lose money. Don't forget to figure in the 75 at the very end. Okay? I'm going to pause while you work on that. So here you go. The works probability. It's a much higher chance it works than it breaks. In fact, it's a 999 out of 1,000, which is 0.999. And there's a 0.001 chance it's going to break. So here's my probabilities. What's my amounts I get? If it works and I go back to the store and you actually show them your working camera, they're going to be like, what? It works. It's supposed to work. They're going to give you nothing. On the break side, if you show them your broken camera, don't they have to give you your money back? Yes, they do. $300. Cash. 0.001 times that gives me, this is kind of weird, but 0.3. It's not 1%. It's 0.1%. 1% would be $3. This is 0.1%. So it's a $0.3. That means this warranty is worth a grand total of, add these together, 30 cents. Isn't that amazing? Yes, sir?
When you subtract 75.
We're going to do that in a minute. We have just figured out what the warranty is worth. Does this mean you're going to make 30 cents if you buy it for $75? No, you're going to lose tons of money. So that's what this is what it's worth. That's not its expected value. The expected value, you have to figure out how much am I going to make or lose. You paid $75 for something worth 30 cents. So you're losing $74.70. That is your expected value. Get that? Here's the key. So many kids get to the end of the problem and they never use the price of the warranty. If you don't use that 75 in your calculation, you know you did something wrong. You got to use the 75. If you don't factor that in at the end, you haven't got the expected value. Think about it. You can't do the problem unless you know how much the warranty costs. You can't tell if it's a good deal or not. What if the warranty's free? Well, then it is a good deal. You're going to make 30 cents because this store gives a free warranty with their product. Yes? So you would here's if you do it that way. If you say it works, the thing that messes with people's heads is if the thing works, You don't go to the store and they give you negative $75. See what I mean? So you can think of it this way, though. If it works, you're going to lose $75 because you wasted the warranty, right? Go ahead. Instead of getting 300, you have to think of it as you're going to take 75 off of that. And yes, if you put it in both those places, but here's the problem with that way of doing it. I got to multiply by 0 doing it my way. You had to multiply that times that and get a more complicated number here and a more complicated number here. And then you had to add the more complicated numbers together and get, you still got the same answer though, right?
Yeah.
Okay, so I just like the way I did it better, but the way you did it is totally okay. All right, so I would wait till the end and figure in the 75. But it is up to you if you want to do it that way where you figure in a negative 75 here because you lose money if the thing works. Just don't do it both ways. You can't include another minus 75 at the end. That would really mess you up. Okay, I think that's enough. Now this is the part where we start our homework. So everybody grab your homework, which looks like this. It's 12.4 part B, worksheet B. And I'll help you get it set up here. I need to shrink this down a little bit so I can see all the parts. There we go. 12.4 worksheet B. All right. There are a whole bunch of different kinds of seats you can get. You can get them in section A, in section B, in section C, or in section D. The ones in section A are 16% chance that you'll get one there, 24% chance for B. Section C is 32% chance, and last one is 28% chance in section D. How much are they worth? The amount, because these were the probabilities. The amount for section A, those seats are worth $35. Section B seats are worth $30. Section C seats are worth $25. Do you get what I'm doing here? And all I'm going to do is probability times the amount. Probability times the amount. Probability times the amount. And then I will add them all up once I get these 4 answers. Okay? B times A, then add them up. This next kind really messes with people's heads because there's no amount that's really easy to tell. The probability is not that hard. You've done trees like this before. Let me see if I can zoom on this. The probability of a boy is 48 and girl is 52. So let me zoom in on this to like 200%. Here's my chart. Girls 52, is that right? Okay. So do you have to go through your whole chart and fill this in? No, you don't. Do you have to get all the numbers at the end? Yes, you do. So you take your calculator and go 0.52 times 0.52 times 0.52, and or 0.52 to the third would be even smarter. And you'd find out it was 0.141 if you round it. So there's my probability of that thing happening. Now let's do one more. This one, you have a 0.48 for the boy, and then you go 0.52, 0.52, and 0.48, and that rounds to 0.1297, so that's going to be about 0.130. Do you get how you can get the probabilities for the whole thing? Then what do you multiply by? Amount. Amount of what? Amount of what? No, that's an important distinction. What are they asking about in this problem? Boys, specifically. Because if it was amount of children, that would be a whole different problem. This is amount of boys. So on this first route, you got the probability times the amount of boys you get on that first route is, you don't get any boys in the first one. Girl, girl, girl. So you go 0. 0 times this. How many boys do you get on this route? 1. Now let's do this route. That one, and that one. That's going to also be 1 boy. So I'm going to multiply it times 1. Get it? Probability of each one times amount. And the amount is, they asked about boys. So the amount of boys I get is 1 here. This will be a 2. This will be worth 1 boy here, 2 boys here, 2 boys here, and the last one is 3 boys. And then I have all my probabilities here, which came from the tree. What do you think I do when I'm all done? Add them all up. And that is the answer. And what does the answer mean? That means the expected number of boys you should have. Remember, we were talking about boys, not kids. That's why the number here at the top is 0. Obviously, they have kids in this route, but it's 0 boys. So when it's all done, what you got is the expected value of boys. And value just means number. Yes?
So you wouldn't count the top one?
You would have a 0 times 0.141. 0 times anything is worth 0. All right. I have done everything I wanted to do with you, so you've got the rest of the time to work now on 12.4 Part B, and then tomorrow, again, right now I'm talking in terms of today is Tuesday. On Wednesday, some kids are actually going to probably watch this video on Wednesday to learn the stuff, and then Thursday we will have the review day, and then Friday you take the quiz on Venn diagrams and expected values. Okay, that's all I got for you for today.